Yes, good morning, students. We will start now. Yesterday, on WhatsApp group, I have sent the deleted and non-evaluative syllabus for year 2021 due to COVID-19. And just now, I also mailed the copy of 11th standard and 12th standard. 11th standard copy I have sent for your information, and the 12th standard copy I have sent for you. Also, I have sent the textbook, which is highlighted with yellow colored marking, and that yellow colored marking, it will be not asked for board exam, remember. So please download it and keep it for your reference. If you click the yellow colored highlighted material, you will get the remark there, which part is eliminated, which part is not asked for board exam. Means whatever the highlighted part is given, it will be not asked for board exam, remember, for this year only. Due to COVID-19 situation, only for this year, this will not be asked for board exam. Next, from the next year, all the syllabus will be there. So again, I am coming to the chapter, this aldehyde, ketones and carboxylic acids. I think yesterday the methods of preparation of aldehydes, ketones, it is explained. In this chapter, many named reactions are there. For example, Stephen reaction, it is asked for 2 marks. Then Rosenman reaction, it is asked for 2 marks. Then Itard reaction, it is asked for 2 marks. Then Friedel-Crafts alkylation, Friedel-Crafts acylation. In this chapter, aldehydes and ketones, Friedel-Crafts acylation reaction is removed. You will see in the deleted syllabus, the details are given. The Friedel-Crafts, I will show which reaction is eliminated. Methods of preparation of ketones. This reaction. Preparation of aromatic ketones from acyl chlorides. This reaction is deleted this year because this reaction is repeated many times. This is also explained in 11th standard. So this reaction will be not asked. And again, the methods of preparation of aldehydes and ketones by using these hydrocarbons. This is also reduced. This one, by ozonolysis of alkenes and by hydration of alkynes. These two reactions are also reduced. So no any question will be asked on this part. Now, yes, yesterday we are discussing about the polarity of carbonyl carbon. See, this carbonyl carbon, it is polar due to the electronegativity of this oxygen. So this oxygen will push the electron density towards itself. It becomes delta negative and the carbon becomes delta positive. See the structure number A and see the structure number D. A and D, all these are resonance structures. Only the electron density is shifted. See the in structure A, the carbon is having delta positive, and in this structure is the resonance hybrid. We can see here this carbon is delta positive, oxygen is delta negative, oxygen is delta negative. So carbonyl carbon is positive polarity. Therefore, it is electron deficient. Electron deficient means it do not having electrons. So nucleophile attacks will be nucleophile will easily attach to this electron deficient carbon. So it is very easy for the nucleophile to attack because of this oxygen. So it is asked for 2 marks for the board exam. Explain the polarity of carbonyl carbon. Only we have to draw the resonance structure and write only 2 lines. Why this is polar and why this is electron deficient. Electron deficient because of this oxygen. Oxygen pulls the electron density towards itself. It becomes delta positive and it becomes delta negative. Now, the reactivity of aldehyde ketones depend upon the groups. In case of aldehydes, you know, to this carbonyl carbon, one hydrogen is permanently attached because the functional group of aldehydes is COH, and one R group is attached or one AR group will be attached depending upon the aromatic aldehydes or aromatic ketones. If the R group is attached, what is happening? If the R group is attached, R group will gives the electron density to this carbon. So if the electron density will be given to this carbon, the this carbon becomes negative. So as the number of R groups increases, the reactivity decreases. In case of aldehydes, only one R group is there. So aldehydes are more reactive than the ketones. See, the aldehydes are more reactive than the ketones towards the nucleophilic attack because of these groups. This is explained on the basis of two effects. There are two effects. One is a plus R effect and one is a steric effect. First, I will explain this what is happening if the two R groups are attached and what is happening if the one R group is attached. See, in case of aldehydes here, see this structure carefully. In case of aldehydes, one R group is attached here. One R group means the it will gives the electron density to this carbon, and this carbon becomes positive. If this becomes positive, the nucleophile will not easily attack. But in case of ketones, see, if we compare the aldehydes and ketones, in case of ketones, there are two R groups. So as compared to aldehyde, in case of ketones, it is more difficult to attack the nucleophile because this becomes more and more negative. For the nucleophilic attack, this should be positive. But if the R groups are attached, this becomes negative because these two R groups will donate the electron density to this carbon. So this is a electronic effects plus R effect. Plus R effect increases, the attack of the nucleophile on the carbonyl carbon decreases because the electron density increases. You should know the reasons why this is happening. So aldehydes are more reactive than the ketones because of one R group and ketones having the two R groups. Then the influence of steric effect. See, in case of ketones and aldehydes, one main important thing is there are two R groups and one R group is there. So what is happening in case of ketone? These are the two bulkier groups. This may be CH3, this may be C2H5. So as the bulkiness increases, it is difficult for the nucleophile to attack. And in this case, in case of aldehyde, it is easy for the nucleophile attack as compared to aldehydes and ketones. I am explaining why these ketones are less reactive and why these aldehydes are more reactive, because aldehydes having only one R group, the nucleophile can attack easily. And in case of ketones, as the bulkiness increases, it is difficult for the incoming nucleophile to attack. So this situation is called as steric effect. Steric effect is due to the bulkiness of the groups. And always one note is given here. Always keep in mind, in case of aromatic aldehydes are less reactive than aliphatic aldehydes. If the question is asked for board exam, explain why aromatic aldehydes are less reactive than aliphatic aldehydes. So your answer should be like this. In case of aliphatic aldehydes, no aromatic group is attached to the carbonyl carbon. But in case of aromatic aldehydes, AR group, aromatic ring, benzene ring, or benzene substituted groups are attached to the carbonyl group. So what is happening? As the R groups are electron donating plus R effect, see, I am explaining why these aromatic aldehydes are less reactive than the aliphatic aldehydes. In case of aliphatic aldehydes, there are R groups, and in case of aromatic aldehydes, there are AR groups. So what is happening? These aromatic aldehydes gives electron density. Due to the electron donating R effect, what is happening? The carbonyl carbon becomes less electrophilic. Means carbonyl carbon gets the negative charge because it is aromatic ring is electron donating. So when the carbonyl carbon is more reactive, one important thing, this should get positive charge. Means the carbonyl carbon always should get the positive charge, then it becomes more reactive. So if we consider the formaldehyde and acetaldehyde, which is more reactive. So formaldehyde is more reactive than the acetaldehyde because in case of formaldehyde, there is no any R group is attached. So the carbonyl carbon becomes positive. as compared to acetaldehyde and formaldehyde. Then chemical properties of aldehydes and ketones, laboratory test. We will do this test in laboratory when the COVID-19 situation will end. This part is also included in the practical, which are the tests for aldehydes and which are the tests for ketones. In functional group detection, we will see this, but I will explain. Many times this is not asked for board exam, remember. So aldehydes are easily oxidized. You know, in the previous reactions, aldehydes are easily oxidized to get the carboxylic acids. Alcohols, primary alcohols on oxidation. I will explain how the aldehydes are prepared. Aldehydes are prepared by using the primary alcohols. When the primary alcohols are oxidized, they get aldehydes, and aldehydes again oxidized, they get the we get the carboxylic acids. So see carefully here, aldehydes are easily gets oxidized. Means oxidation of aldehydes is done, so they are acts as a reducing agent. In 11th standard, we learn these things, what is mean by oxidizing agent and what is mean by reducing agent. Aldehydes are easily gets oxidized. Yes. Aldehydes are easily gets oxidized to carboxylic acids, and therefore these are acts as a reducing agents. So reducing agents are the substances they itself gets oxidized and causes the reduction of others. Just a minute. We will start again. Yes. Yes, here. Aldehydes easily gets oxidized to carboxylic acids. These are acts as a reducing agents. Now, ketones do not have the hydrogen directly attached to the carbonyl carbon. The main difference in between aldehydes and ketones is groups attached to the aldehydes and ketones. In case of aldehydes, the hydrogen is directly attached. See, if you see the structure of aldehydes and ketones, you know. Yes, see here. In case of aldehydes, the hydrogen is directly attached to this carbonyl carbon, and in case of ketone, there is no hydrogen attached. So aldehydes are easily gets oxidized because of this carbon, and ketones are quite difficult to get oxidized. Then, so due to the basis of this difference, reactivity of aldehydes and ketones are distinguished by the following tests. There are two tests which we are doing at the laboratory. One is CIPS test. CIPS test, when the solution of aldehyde, alcoholic solution of aldehyde, means aldehyde we have to take in the test tube, plus we have to add a little amount of alcohol, and it is treated with few drops of Schiff's reagent. Schiff's is a specific reagent which is used for the test for aldehydes. We get the pink red color or magenta type colors, it is appeared, and it is the gives confirmation of aldehydic group, remember. So in the laboratory at the time of board exam, you have to do this test, Schiff's test, Schiff's reagent we have to use, and we get the red color or pink color or magenta color is appeared, and it is a confirmation of aldehydes. Ketones do not give this test, only aldehydes gives this test. For the CET exam, this question is asked. See, benzaldehyde gives the tolerance as well as Schiff's test, but they do not give the failing solution test. Why this is happening? So the main reason is, in case of benzaldehyde, they do not contain alpha hydrogen. If the alpha hydrogen is not there, so enolate ion will not be formed. So if the enolate ion is not formed, further it do not react with the failing solution test. So this question is asked for CET, NEET, and also the JEE exam. Remember this question will not be asked for board exam. Then tolerance test or silver mirror test, you can do this test for the detection of aldehydes also. In laboratory, we will perform this test. Tolerance test, what is this mean? Tolerance test is related to it is also called as silver mirror test. And for doing this tolerance test, we have to use the tolerance reagent. Tolerance reagent is ammonical silver nitrate solution. In the laboratory, we have to take one test tube, we have to add the aldehydic solution, it is boiled with tolerance reagent, we get the silver mirror inside the test tube. Means silver mirror means if you saw the mirror and behind the backside of the mirror, silver colored, like this silver colored compound is formed. So such type of compound is appeared in the test tube. So this test is actually very costly because the silver nitrate solution is very costly. So in many institutes, this test will not be performed, but we perform such test. I will show when the COVID situation will end. Then next test is failing test. This is another test used for the detection of aldehydes and ketones. When a mixture of aldehyde with the failing solution, there are two failing solution, failing A and failing B solution, which is mixed together, and the test tube is boiled in hot water. We get the red precipitate of cuprous oxide. So all these tests we will perform in the laboratory. This is a knowledge, extra knowledge I have given for this will not be asked for exam. How the ship's reagent, red magenta color is formed. SIPS reagent is a para-rosanilin. Don't remember these structures. For the information purpose, I have given this test. What is actually happening? How the red or magenta color is formed. Now, most important thing, this sodium nitroprusside test is non-evaluative for this year. Test given by the ketones. This test is non-evaluative. It is deleted from the syllabus for this year. So make a mark there. Sodium nitroprusside test. This is not asked for your board exam. Yes. Now the reactions of aldehydes ketones are started here. First one is addition of hydrogen cyanide here. HCN. Hydrogen cyanide in this hydrogen cyanide, this CN is minus and hydrogen is plus. It is a weak acid. So CN minus is acts as a nucleophile. It will attacks on the carbonyl carbon. Carbonyl carbon, now you know this carbonyl carbon is electron deficient and it will easily attacks to the carbonyl carbon. I will explain first this general reaction. In case of aldehydes and ketones, the main difference is R group is attached, and in case of aldehydes, H group is attached here. So what is happening in this HCN, the CN minus will attach to this carbonyl carbon. So the electron density will be shifted on the oxygen, and this hydrogen is picked up by the oxygen, and we get the product cyanohydrin here. So this reaction is asked for 1 mark for the board exam. Cyanohydrin formation. If aldehyde is used, the compound is called as acetaldehyde cyanohydrin, and if the ketone is used, it is called as acetone cyanohydrin. The main difference is between aldehydes and ketones, otherwise reaction is same. HCN is used in both the reactions. CN minus is acts as a nucleophile. CN minus is acts as a nucleophile. It will attach to the carbonyl carbon. We will get the minus charge here, and this minus charge will pick up the hydrogen from this, and we get the cyanohydrin. So remember, cyanohydrin preparation by using aldehydes and ketones is done by using HCN. HCN is a weak acid. So it is a simple nucleophilic addition reaction, because the addition takes place across the CO double bond. It is not substitution reaction, it is nucleophilic addition reaction. Remember, no any group is substituted in this. So this is nucleophilic addition reaction. Now the addition of sodium bisulfite, it is NaHSO3. It is same as the addition of hydrogen cyanide. sodium bisulfite is NaHSO3. In this, see the group which is attached, NaSO3. So NaSO3 is negatively charged. It will attacks again, same mechanism is there. It will attacks to the carbonyl carbon. The electron density will be shifted. This becomes O minus and it will pick up the hydrogen. And we get the acetaldehyde sodium bisulfite. It is the product. It is also called as addict. In case of ketones, the same reaction takes place. SO3Na. This SO3Na, it is negatively charged. It will attach to the carbonyl carbon. Again, electron density will be shifted to this oxygen, and this oxygen will pick up the hydrogen, and we will get the product acetone sodium bisulfite product. So this may be asked for 1 mark. Then next one, addition of alcohol. This is very, very important. Make a mark there in your textbook and notebook also. This is a acetal formation and hemiacetal formation reaction. Very important, make a note there. Aldehyde reacts with one molecule of anhydrous alcohol. See the general reaction I will explain. This is aldehyde plus R-OH or ROH. This is a alcohol in presence of dry HCl and in presence of dilute HCl. It is used as a solvent. Hemiacetal formation takes place here. See what is meant by hemiacetal, I will explain. Hemiacetal contains this OR dash group and one OH is there. Such group is called as hemiacetal formation. And instead of this OH, if the two OR groups are there, see here, it is called as acetal. So this is hemiacetal, means half acetal, and this is complete acetal. Acetal and hemiacetal. First, hemiacetal is formed when the aldehydes reacts with alcohols. Say it is a simple reaction. This is also the nucleophilic addition reaction. Addition takes place across this CO. This OH attacks here. Electron density will be shifted and this R will be picked up and we get the hemiacetal. It is very unstable. In the second step, what is happening? Again, this hemiacetal reacts with one molecule of alcohol and we get the complete acetal. So when the acetal formation is completed, reaction will be stopped. And in case of hemiacetal formation, it is unstable. So reaction will not stop at this stage. When the acetal is formed, the reaction will be completed. It becomes stable. So this reaction many times asked for the board exam. Remember how the acetals are formed. So this is a general reaction. I will take one example. This is acetaldehyde, CH3COH plus C2H5OH. C2H5OH is there. In presence of HCl, we get the CH3CH, CH3CHOH, and O C2H5 here. This is hemiacetal. It is unstable. Again, it reacts with one molecule of C2H5OH. We get the complete acetal formation here. Now, what is the name of the compound? 1,1-diethoxy, because these two are ethoxy group, diethoxyethane, which is very stable. So we can take any aldehyde and we can form the acetal and hemiacetal preparation. But in case of ketones, see, ketones, they form the cyclic ketals. When glycol is there, these are the two R groups, any ketone, CH2OH, CH2OH, this is ethylene glycol. These are also called as diols in presence of dry HCl. We get here the cyclic ketals here. So see how the cyclic ketals are formed. This R group is same as in case of ketones. This carbon, this OH attacks. This one of the OH attacks to this carbonyl carbon. Again, electron density will be shifted, and we get the cyclic ketals here. So this is the exception. Remember, aldehydes gives acetal and hemiacetal, but the ketones gives cyclic ketals. Remember. Then again, the addition of Grignard reagent many times now from the halogen derivatives, alcohols, also in case of aldehydes addition of Grignard reagent. Now you are familiar with the Grignard reagent. Many times this is asked for exam. Grignard reagents, these are organometallic compounds. How it is prepared in halogen derivatives, you know, it is prepared with by using magnesium metal, by using alkyl halides in presence of dry ether. It is prepared. So this is RMgX. This R having delta minus charge, X is also having delta minus, and this Mg having the 2 delta plus. So this R groups attacks on this carbonyl carbon. See, the arrows are also shown here. This reaction is very, very important. In carboxylic acids also, the methods of preparation of carboxylic acids by using dry ice. This reaction is also we learned in the previous part. Grignard reagent when reacts with the dry ice. Yesterday I explained this reaction. They form the carboxyl. The mechanism is same like this. So these R groups will attack here. Electron density will be shifted. This O minus will pick up this. Just a minute. So see, this O minus will pick up the remaining MgX, and we get the intermediate here. And after hydrolysis, we get here alcohols, and this is byproduct. So we can prepare the primary alcohols, secondary alcohols, and tertiary alcohols, depending upon the aldehydes are used here. If the formaldehyde is used, the general reactions are shown here. If the formaldehyde is used, HCOH, this R will attacks. We get this intermediate, and the alcohol is primary. When the acetaldehyde is used, we get the secondary alcohols. When the ketones are used, we get the tertiary alcohols. So make a practice at your home. This reaction is very, very, very important. Methanol gives primary alcohols, and methanol means this is IUPAC name of formaldehyde. Then other aldehydes produces secondary alcohols, and ketones gives tertiary alcohols. You can take any aldehyde and make a practice at your home. Any aldehyde you can take. You can take aromatic aldehydes also. You can take aliphatic aldehydes also and make a practice at your home. So these are the very interesting reactions. All the Grignard reagents reactions are very interesting. You having lots of scope. You can take any aldehydes. You can take aromatic aldehydes also. You can take aromatic ketones also. 10 minutes are remaining. Then next part is nucleophilic addition, elimination. Now this addition and elimination means addition will be takes place, and side by side elimination also takes place in this reaction. All the reactions are the same pattern. So what is this reaction? These are the reactions with ammonia derivatives. Ammonia derivatives means ammonia is there. Ammonia is NH3. One hydrogen is replaced by the Z group. NH2Z group, it is called as ammonia derivatives. These are the derivatives of ammonia in which one hydrogen of ammonia is replaced with Z group. And what is mean by Z? See here, what is Z? I will explain. Z, it may be R group, it may be ER group, it may be NH2, it may be NHC6H5, it may be NHCONH2, it may be NHC6NH3NO2. All the reactions are same. All the reactions are same. So what is happening in one reaction I will explain, and other reactions you can solve. See, this is a carbonyl carbon CO, and this is ammonia derivatives NH2Z. So what is happening? This oxygen and these two hydrogens. See, this oxygen and these two hydrogens, it will remove water molecules, and imine type of product is formed. What is imine? C double bond ON. C double bond ONZ. Such type of product is called as imine. So in all the reactions, imine will be formed. So first I will take this example. This is acetaldehyde. See, this oxygen and this NH2 groups. Out of this NH2, this H2 and this O will be removed, and we get the bonding like this, C double bond ON. C double bond ON bond is called as imine group. Don't remember this intermediate directly. You can write the product here. This is called as oxime. When hydroxylamine is used, we get the oximes here. So what is hydroxylamine? Hydroxyl, this OH is hydroxyl and this is amine. So when hydroxylamine is used, we get the oxime, acetaldehyde oxime. If the ketones are used, we get here ketone oxime. See, all the general reactions are shown here. If the hydroxylamine is used, we get here oxime. Now the hydrazine is used. So what is hydrazine? I mean the NH2, single bond NH2. This is called as hydrazine. When these two hydrogens and one oxygen will be removed, and we get here hydrazone. The mechanism of the reaction is same. H2O molecule will be removed, but these groups are different. Hydroxylamine, oxime, hydrazine, hydrazone. Then this is phenyl hydrazine. Phenyl hydrazine means this phenyl group is attached. C6H5. This is phenyl group, and this is again hydrazine. So these two hydrogens and one oxygen will be removed. We get phenyl hydrazone here. Then semi-carbazide to semi-carbazone. These two hydrogens, the oxygen, water molecule will be removed. So semi-carbazide, when reacts with aldehydes or ketones, they forms semi-carbazones. And last one is 2,4-dinitrophenylhydrazine. 2,4-dinitro means this is carbon number 1, this is carbon number 2, this is carbon number 3, this is carbon number 4. On the second and fourth carbon, 2-nitro, 2,4-dinitro. This is carbon number 2, this is carbon number 2,4-dinitro phenylhydrazine. Means if you understand the phenylhydrazine, to understand phenylhydrazine, you must know hydrazine first. So hydrazine is NH2, NH2. One hydrogen is replaced with the phenyl group. It is called as phenylhydrazine. And see, this is also phenylhydrazine, NH2, NH, C6H5. But only what is the change in between phenylhydrazine and 2,4-dinitrophenylhydrazine is only at the second position and fourth position nitro group is there. Otherwise, the reactions are same. Phenylhydrazine is same, hydrazine is same, 2,4-dinitrophenylhydrazine. Only the compounds are different, but the reactions are same. Water molecule will be removed, and we get the hydrazones here. See, in case of this hydrazine, hydrazones are formed. Phenylhydrazine, phenylhydrazone is formed, and 2,4-dinitrophenylhydrazine. Now we get 2,4-dinitrophenylhydrazone. So one thing only we have to remember, all these ammonia derivatives reacts with aldehydes and ketones, water molecule is removed. This is a simple thing behind all this. All the reactions are same. Only at the type of board exam, they will ask any one of this reaction, and the reaction will be like this. What will happen when hydrazine reacts with aldehydes? What is the reaction of hydrazine with ketones? What is the reaction of phenylhydrazine with aldehydes and ketones? So if aldehyde is given or ketone is given, you know, so only we have to remove the water molecule here. Oxygen of this carbonyl carbon and two hydrogens of the ammonia derivatives, we have to remove it, and we get the C double bond ON. Such type of compounds are called as imine derivatives. Remember, imine, IMINE. It is not amine, it is imine derivative. Imine means C double bond ON group. This is CON group. This is a imine intermediates, and amine means RNH2 group. It is a totally different. So these are nucleophilic addition elimination reactions. Why addition reactions? Because addition takes place across the double bond. And why elimination reaction? Because water molecule is removed. So this is nucleophilic addition elimination reactions. Then just I explain what is this Z. Z, it may be R group, it may be R group, it may be NH2. So number of ammonia derivatives are prepared, and we get the imine intermediate. So this is one homework is given based on these ammonia derivatives reaction. Solve at your home. These are very simple. Only we have to form this bond there. This oxygen will be removed, and we'll get this C double bond O N bond. So these two hydrogens and one oxygen will be removed. this oxygen and these two hydrogens will be removed, and we get the imine intermediate product. Now the structure of the following also, these are the very creative homeworks I have prepared by using the different books. Means if you are able to solve these homeworks, means you, it means that you understand the whatever the part I have taught. So make a practice at your home. Then one of the important reaction which is asked for the CET. Mainly this reaction is asked for CET. Many times this is asked for CET, haloform reaction. Haloform, what is meant by haloform? I have to explain, and what are the conditions required to prepare the haloform. Haloform is prepared by the reagents which are very important now. The reactants means all the, this reaction is given by the aldehydes. See, all the aldehydes, all the aldehydes do not give the reaction, only one aldehyde, this is acetaldehyde. Acetaldehyde is having CH3 group is bonded to the carbonyl carbon. So this haloform reaction required specific type of reactants. This reactant should contain CH3 CHOH group. See, if the such type of group is present in the reactant, then it will be undergoes haloform reaction. So the main condition is this one, CH3 CHOH, means methyl group should be there. So only methyl ketones gives these reactions. And why acetaldehyde gives this reaction? Because acetaldehyde also contains the methyl group. And alcohols containing CH3 CH group, means CH3 is a very important here. If the methyl group is not there, they do not undergo haloform reactions. So for the undergoing haloform reaction, CH3CH, this group is must. When alcohol containing CH3CH group or methyl ketone is warmed with sodium hydroxide, iodine, and iodine, we get the yellow precipitate. This yellow precipitate is called as haloform. This reaction is takes place in presence of sodium hypoiodide solution, NaOI. This NaOI is highly unstable. It is prepared in the laboratory at the time of reaction. It is called in situ. It is prepared. In situ it is prepared. So see the example, then you will understand how the reaction takes place. Acetone, when it is treated with sodium hypoiodide solution, NaOI, this NaOI is prepared in situ, NaOH, reaction of NaOH and I2, we get here yellow colored compound, iodoform, CHI3. This is main product, and we will get the sodium salt of acetic acid. This is sodium salt. This is sodium, and this is